Hello everybody, I welcomes all of you to this next lecture regarding signal generators and analyzers. Okay, so I think we have completed signal generators and now we have to move towards the signal analyzer. Okay, so if you see this unit, this is very simple, and if you see different types of signal generators, most of the things were common, so that's why we have covered that quickly. Similarly, if you see the signal analyzer as well, most of the different signal analyzers internal diagram is same, so that's why here also we will not require much time to complete this, but you must know how practically it is used. So that's why in between I am sharing videos of that demos, how to use signal generator, and regarding this signal analyzer as well I will share one video, because that is again very important. Okay, so you will understand the block and its working, but practical working is very important, so that's why I am sharing the demo videos with you, so that you can understand practically. That is again very important. Okay, so let's start with this signal analyzer. So let's understand first what is the signal analyzer. So it is used for analysis of electric signals. Okay, now if you see the electrical signals, there are different types of electric signals which are available. Different types of timings are important, different types of frequencies are there, and we have to see the power as well. Okay, so analysis of electrical signal is most important thing in circuit debugging, we can say. Okay, so if you see the different types of signal analyzers, that can be classified like wave analyzer, distortion analyzer, most important is spectrum analyzer, and then logic analyzers. Okay, now we have to start with the spectrum analyzer. Okay, so let's start with this. Now let's understand first what do you mean by spectrum analyzer. Okay, so what do you mean by spectrum first? Okay, so the study of energy distribution of a signal as a function of a frequency is called as a spectrum analysis. Okay, so if we must know the energy distribution of a signal as a function of a frequency. So till now we have seen the signal's amplitude with respect to time. Okay, so now we must know the signal's amplitude with respect to frequency, and that is nothing but a energy distribution of a signal as a function of a frequency. Okay, so the instrument which graphically represents energy distribution of a signal as a function of a frequency and CRO can be called as a spectrum analyzer. Okay, so if you see the cathode ray oscilloscope which shows you time versus amplitude axis, okay, so same CRO, if it is showing you the function of a frequency and we can say amplitude, then that can be called as a spectrum analyzer. Okay, so this study gives information about bandwidth, then types of modulations which are used, then how the signal generation is done, modulation index, attenuations, then component levels. So these information we are getting from spectrum analyzer. Okay, so like signal generator, we will study one spectrum analyzer in depth, and then I will give the idea about the another spectrum analyzer which will be similar to the basic spectrum analyzer. Okay, now in case of a oscilloscope, as discussed earlier, signal is plotted as a function of a time, that is amplitude versus time, and that is called as a time domain analysis. Okay, but if you see the spectrum analyzer, the signal is plotted as a function of a frequency, and this analysis is called as a frequency domain analysis. So in short, we can say that the spectrum analysis spectrum analyzer is giving you a frequency domain analysis. Okay, and the spectrum analysis can be done in two ranges of frequency. There is one range is called as AF range, which is audio frequency range, and another is a radio frequency range. Okay, now if you see here the diagrams are showing you the much information about the spectrum analyzers. So if you see this third diagram, that is very important. So here two frequencies are given, F1 and 2F1. Okay, so here the amplitude of F1 frequency is higher and the amplitude of 2F1 frequencies we can say smaller than this one. So this is amplitude versus a frequency. Okay, So here a three-dimensional representation of a signal is shown in this figure A. It shows time, frequency and amplitude at a time. So if you see, this is our time, this is amplitude. From this side you will see this signal as an CRO. Okay, and if you see the amplitude versus frequency from this side, suppose if you see, you will see the straight lines like this. So for this one you will get the straight line like this, and for this second frequency you will get a straight line like this. Okay, and here if the same signal is observed on oscilloscope, then the time domain representation will be like this. And if the signal analyzer is used, if spectrum analyzer is used, we can say, then frequency domain representation will be like this. Okay, so this is the signal which is represented in two domains, time domain, frequency domain with respect to amplitude. This is with respect to, we can say, time and amplitude, and this is with respect to frequency and amplitude. The same signal is represented over here. Okay, so the output will be like this. We have to concentrate on this one. Okay, you will get a graph like this. That is very important. Okay, so this is a basic difference in between cathode ray oscilloscope and a spectrum analyzer. Again, I am repeating, one important thing is that whatever the CRO tube that we are using in a CRO, normal CRO, same is used in spectrum analyzer, but here we are plotting the signal's amplitude with respect to frequency, whereas in normal CRO we were plotting the amplitude with respect to time. That is the difference that you have to keep in mind. Okay, so let's move forward with this basic information. Now let us see the block schematic of a spectrum analyzer. So if you see this diagram, this is a block schematic of a simple spectrum analyzer. So here if you see the normally RF or microwave signal, for the RF or microwave analysis of a signal or signal analysis, this sweep technique is preferred. Okay, so if you see this block diagram here, this can be scanning or non-scanning type. Okay, so here we will see the basic structure of the spectrum analyzer first. So if you see here, there is one sawtooth generator. This generates the sawtooth wave. I think this part is covered in CRO and you are aware about this sawtooth wave. Okay, so this sawtooth waveform is applied to the horizontal plates of a CRO. So here they are applied to the horizontal plates. Now this sawtooth signal is also applied to the voltage tuned local oscillator. Okay, so this voltage is applied to the voltage tuned local oscillator or tuned oscillator, we can say, and this acts as the frequency controlled element of the local oscillator. Okay, so why it is called as frequency control? Because when the sawtooth signal is applied to this voltage controlled oscillator or voltage tuned local oscillator, its frequency changes from Fmin to Fmax. Okay, and the RF input signal which is applied to the mixer over here, that is mixed with this output of this voltage tuned local oscillator. Okay, now as per this input signal, this output is managed over here based upon the sawtooth waveform. That is very important, because as per this input only this should be tuned and the signal's frequency should be we can say adjusted from this range, and it is mixed over here. I think if you see this, the most concepts, the RF and mixer and IF, these are from electronic communication system. I don't know whether you have studied or you will study this in future, but all these concepts are from that electronic communication system. Okay, but I will not waste the time to explain that what is IF and all other things. Okay, because this is covered in electronic communication system. What do you mean by intermediate frequency and why it is chosen? Okay, so this is your homework. Just see what do you mean by this IF and why it is preferred in communication system. In most circuits you will observe this mixer, voltage tuned oscillator, and this IF amplifier and detector. Okay, so these four things will be common in most of the communication circuits. I will not waste much of time to this, because we have to cover this unit. Okay, so I will just give an overview about this. Okay, so just this is your homework. Please see that what is the use of intermediate frequency and why it is chosen, why it is used in communication system, that you have to search on Google. Okay, so this RF input is applied to the mixer, and the output of this voltage tuned oscillator is used to beat with the input signal in order to produce the IF frequency. Okay, so this is adjusted, this phenomena or this all other things are adjusted to get IF frequency. That's it. Okay, and this IF component is produced when the corresponding component is present in the input signal. So based upon the input component, the IF frequencies we can say selected, okay, and this resulting IF signal is applied to detector and video amplifier. So I am talking about the component, corresponding component present, means what, if you want to select some range, component means what, some range of a frequency, that for that frequency this voltage tuned local oscillator is adjusted, okay. So that is nothing but a definition of a component. Component means what, some frequency range, for that frequency range it is just adjusted to produce the IF or intermediate frequency. That is so simple explanation of this. Now if the IF this corresponding we can say IF component is amplified and detected, okay, and if it is after detection and amplification, if it is applied to we can say vertical deflection plates of a CRO, then it produces the plot of amplitude versus frequency like shown over here, because we have applied a sawtooth wave here, and whatever the selected component of a signal or IF, we can say it is detected using generally envelope detector, and it is amplified with using video amplifier, and when you apply such a signal at the same time over here and here, it produces the amplitude versus frequency plot like this, okay. So this is the frequency and this is the amplitude. So this is the basic CRO tube, okay, and all other functionalities different as per the spectrum analysis internal circuitry, okay. So this is the basic blocks schematic of a spectrum analyzer, okay. Now I think you got the idea behind the spectrum analyzers. Just keep 2 to 3 things in your mind, that this assembly is same as a CRO, but the deflection signal that we are applying, that is different. This is again same sawtooth generator. This sawtooth generator generates sawtooth wave, and it adjusts the frequency of this voltage tuned oscillator from Fmin to Fmax. So this Fmin to Fmax should be adjusted as per this RF signal to produce IF signal, and when this IF signal is amplified, detected and again amplified and applied to this vertical deflection plates, where horizontal deflection plates are applied to the sawtooth generator, then it is producing the amplitude versus frequency plot. This is the simple working of any spectrum analyzer, okay. Now I think this much is sufficient, this explanation is sufficient. Practically I will share one video with you that will give you idea about the spectrum analyzer, okay. That is a nice video, you have to watch that. Now another type of a spectrum analyzer which is called as a harmonic mixing spectrum analyzer, okay. So I think again, if you see this voltage tuned oscillator, then sweep generator, detector, IF amplifier, mixer, all other things and all these tubes, these are same, only the changes are over here. So these changes are due to the harmonic mixing in a spectrum analyzers, okay. So in spectrum analyzer, normally the input signal is mixed with the fundamental frequency of a first local oscillator, okay, that we have seen. If you use the harmonic mixing, we can say harmonic mixing is used to extend the frequency range of a super heterodyne spectrum analyzer. And if you see this block diagram is a harmonic mixing spectrum analyzer, okay. So harmonic mixing means what? Harmonic mixing means mixing the input signal with fundamental second harmonic, third harmonic of the first local frequency. Again I am repeating, whenever we are doing harmonic mixing refers to the mixing the input signal with a fundamental, this input signal with a fundamental second harmonic, third harmonic, okay, etc. of the first local oscillator frequency, and this is done with the help of this YIG band pass filter and this 2 gigahertz we can say low pass filter, okay. So here for higher order of harmonic mixing modes, the band pass broadband filters which are shown over here, these are preferred, okay. So if you see such type of analysis, it gives the response to the signals which differs from fundamental frequency by 2 gigahertz, okay, and it also gives the response to the signals which differed by 2 gigahertz of the second or third harmonic we can say. And generally if you see this such type of spectrum analyzer, its range varies from 10 megahertz to 12 gigahertz. Okay, so what is the difference between this type of and this one? Here this is used for, we can say, suppose there is one X signal, and this is used for we can say harmonics or multiples of that X signals, so that we can get more flexibility. Okay, so the main idea behind this harmonic mixing is it is used to obtain the response to a several input frequencies simultaneously. Okay, and there are several input frequencies. In order to avoid confusion, the different filters like this band pass filter and all other filters, like, they are used. Okay, so these are again multiples. So this is nothing but harmonic mixing type of a spectrum analyzer. Now next is super heterodyne type of RF spectrum analyzer. Okay, so again if you see, again the same things are there: sawtooth generator, mixer, IF amplifier and detector. So that's why previously I have told you that all other this signal generator and function generators are similar, just different basic things are highlighted in each type of analyzers or function generators. Okay, now the major application of a spectrum analyzer is to study the radio frequency spectrum produced in the microwave instruments. Okay, and if you see this such a microwave frequency range, the signals are separated by only a few kilohertz. Okay, and these signals can individually studied by using spectrum analyzers. Okay, so if you see here, it is super heterodyne type of RF spectrum analyzer. Again, in electronic communication system, you will study this super heterodyne type of circuits. Okay, in modulations types. Okay, so here if you see the working of this spectrum analyzer, the output of a sawtooth generator again here is applied to the voltage tuned local oscillator. Okay, and the horizontal deflection plates of the CRO. Okay, so as discussed earlier, it is generating the sawtooth wave. It is applied to the horizontal deflection plates, as well as it is applied to the voltage tuned local oscillator. Now in case the voltage tuned oscillator produces the frequency from 2 gigahertz to 3 gigahertz. Okay, now an input signal that we have to see here, the input signal which is applied to the low pass filter over here. The range of this input signals varies from 0 Hz to 1 gigahertz, and this signal is mixed with the output of this voltage tuned oscillator. Again the same thing is used, just the frequencies are mentioned and the input signal frequencies mentioned over here, because the signals are separated. If you see the microwave frequency range, the signals are separated by few kilohertz. So that's why we have to study this super heterodyne type of a spectrum analyzer. Okay, now the mixer consists of two signals that are proportional. The mixer consists of two signals that are proportional in amplitude to the input signals. Okay, and the frequency of these signals are proportional to the sum and difference of the input signal and local oscillator frequency, and the output of this mixer is again applied to the IF amplifier. This IF amplifier is nothing but we can say tuned to the narrow band about 2 gigahertz based upon our requirement given over here. Okay, and the frequency of the local oscillator is 2 to 3 gigahertz discussed earlier. Okay, now the input signal which are separated from voltage tuned oscillator by 2 gigahertz will be only converted to the IF frequency band over here. Okay, and the output of this IF amplifier is now applied to the detector and then applied to the we can say here vertical deflecting plates of the CRO. Okay, so, and due to this phenomena again it is producing amplitude versus frequency component or a plot on a CRO screen like this. Again I am repeating these are similar blocks which we have previously studied. This is the basic spectrum analyzer which does not show you any specific range of a frequency. Harmonic is nothing but multiple input frequencies separated by decided range. Okay, and again the super heterodyne type of RF spectrum is given for this range. So only we can see that we can observe here is that only the frequency range is changed and all other things are similar, but it is used for particular applications that you have to note. Okay, so this is all about the super heterodyne type of a RF spectrum analyzer. Okay, now the next thing that we have to study, that is a logic analyzer. Okay, so I think we have studied CRO or normal oscilloscope, which deals with the time domain analysis of a signal. Then we have seen one another type of equipment or instrument, that is spectrum analyzer, with deals with frequency domain. Now previously we have discussed about one field, that is embedded systems. Okay, and in embedded systems most of the signals are in digital in nature. So in that case something is required for doing analysis in digital domain, and that is nothing but your logic analyzer. Okay, so why the logic analyzer is important, let me explain this. Because if you see any digital circuit or embedded circuit, there are different types of digital signals are present over there, clock signals are there. Okay, so at the same time we have to take the number of test points, and we have to see the relation in between that, whether there is a glitch or not, whether there is a timing errors or not, whether the signals are synchronous or not. In that case some type of instrument is required which can accept n number of digital signals at a time and give you a plot on the screen about the timing parameters of that multiple signals. So in that case, this most important thing or most important equipment or instrument which is preferred in industry, most of the industry, that is nothing but a logic analyzer. So if you see high level embedded system courses, in that case while troubleshooting or while doing a debugging of that circuit, they are using a logic analyzer. So this is again very important to analyze the digital domains. Okay, so suppose let me discuss one another point, that is, suppose we have to analyze memory chip which is soldered on a PC board. Okay, suppose we have to see the inside contents of that memory. Okay, so in order to analyze the memory chip, what we have to do is that we have to convert that signals into analog one. Okay, so that will be a very tedious job because there are number of signals, and they are very larger in number, and they are digital in nature. So it may be like TTL or CMOS logic levels. Okay, so in that case logic analyzer will be able to sense and display the address bus, data bus, memory read, memory write, IO read, IO write signals. Okay, and all these tasks is achieved by this logic analyzer. That's why this is very important instrument in digital domain, we can say. Okay, so here if you see the logic analyzer block diagram, here probes are shown. Okay, so these probes we can say are used to take the signals, multiple signals, and it is connected to, we can say, internally connected to the clock generator, then memory, then trigger block and storage qualifiers. And after, if you see here there is user interface as well. That is most important thing, because suppose if you want to see that signals on a screen, then it will be connected to the screen. Suppose if you want to observe this at a remote interface, then we can use RS-232 interface, local area network, or IEEE 488 interface, and there are different control signals which are used or generated by this. So if you see the logic analyzers, you can Google and you can get the images of that, how it is used. It is very interesting to use. So just we have to connect to the multiple test points, and it will give you the overall idea about the timing constraints. Okay, don't worry, I will share the video of this logic analyzer as well with you to study that. Okay, so here as I explained earlier, the logic analyzer displays signals from many inputs at a time, and it may be 16, 32, 48, 64 or even more than that. Okay, and the logic analyzer shows the display in sequence of instructions that have occurred. It responds to logic levels. It is called as logic analyzer because it responds to logic level, that is, it only displays logic 0 or logic 1 state of the input signal. Okay, why it is called as a digital domain analysis? Because in digital domain there are only two languages, language of 0 and language of 1, means binary language. Okay, so that's why it is used to display only logic 0 and logic 1 state of a input signal. It takes the input samples and store the samples in its own memory, so which is high speed memory. Okay, so what is the use of this trigger block? This trigger block generates a trigger signal. This trigger block generates the trigger signal, and the memory system continuously writes the data till the trigger signal is received from the trigger block. So whenever the trigger signal is there, this high speed memory receives the signals and writes continuously data in a memory. Okay, so this is the use of the trigger block. So memory must be high speed memory because it is taking multiple signals, storing of multiple signals and sending data to the user interface. So that's why it must be very high. So high speed memory stores the samples value as I discussed earlier, and the typical memory depth is hundreds of thousands of samples. Okay, so the logic analyzer can store up to several mega samples, that you have to keep in mind. Okay, and so for that purpose the address of the sample in the memory can be internally supplied. So this addressing is done, means to apply the address and the data lines, and that is done internally with the help of control signals. Okay, so the probes, what is the use of probes? I have discussed earlier. It is used to take the signals from the circuit. Okay, so there are different logic families again available, like TTL, CMOS and NMOS. So based upon this the design will be different. Okay, so if you see what is the use of this logic analyzer, another important thing is that it is used to identify the malfunctioning of the system. Okay, suppose there is a system which is not working properly, so if you want to debug that system, then you can use this logic analyzer. Now the logic analyzer can be of two types. One can be a logic timing analyzer and another can be logic state analyzer. So in logic timing analyzer, a data is sampled as a clock signal is generated and at a regular intervals. Okay, and the data sample is stored in a memory like this with the help of this trigger block and all other things. It is stored in memory, and this stored information is displayed. So it is preferred for troubleshooting of problems related to computer hardware, and generally this method is called as asynchronous method. Now if you talk about the logic state analyzer, this was the logic timing analyzer. In logic state analyzer, the data is sampled when the clock signals are synchronized with the measured device. The data sample is again stored in memory, and this stored information is displayed in the form of a binary or hexadecimal format. Okay, and whenever you want to do the software troubleshooting, then such type of logic state analyzers are used. Okay, and it is synchronous method, means again I am repeating two methods we have discussed. One is logic timing analyzer, which is asynchronous method, which can be used for troubleshooting of computer hardware. Okay, and whenever you want to do some troubleshooting of software, then synchronous method is used, where the clock signals are synchronized with the measured device. In timing analyzer, the clock is not synchronized. Okay, but it is, we can say, sampled as a clock signal is generated and at regular intervals. So this was all about the timing analyzer and logic state analyzer. Okay, so this block is again, a block diagram is very simple. Just signals are taken with the help of probes, clock is there, memory is in memory, it is stored, and at a time it is displayed on a screen or user interface based upon that. Okay, in simple one or two lines, if you want to explain this logic analyzer, it will be like this: taking the signals from the circuit, digital signals, that is very important, at the same time multiple signals, n number of signals, even more than 100 at a time, and that displaying that in the form of zeros and 1 on a screen at a time, and just we have to compare the that different signals as per our requirement. Okay, so this was all about the logic analyzer. Okay, so I think this unit was very simple, and we have completed that unit very quickly, because most of the signal generators are same in nature, block diagrams are same, and it was similar to the signal analyzers as well. Okay, so if you want to do more study, you can Google and you can get more data about this. Okay, but to get the practical knowledge, I am sharing the video of that. Please see that video. Don't take only theoretical knowledge, take the practical demonstration knowledge which will help you in the future. Okay, so that's why I am searching a perfect video for you and sharing that with you, because studying only block diagram will give you a theoretical knowledge, but practically how it is used, it will give you a more knowledge. But in practical purpose or in practical sense, if you see, there are n number of analyzers and we can say signal generators are available, but as the basic things required for your study, as per that I am sharing the videos with you. Okay, if you search on YouTube, you will get number of videos on that. Okay, each company will be having different feature. Okay, so there are number of companies are available, and nowadays modern signals generators are available. One thing I forgot to tell you is that if you see nowadays, the CRO comes with spectrum analyzer, logic analyzer as well, means and function generator as well, as well. So if you see, one device gives you the functionality of CRO, signal generator, function generator, spectrum analyzer, but cost will be very high. Okay, so this is again another important thing that I want to mention here. Okay, so just Google on internet and you can get more data about that. Okay, so I have just given you overview because we have to complete the syllabus in this month, and you have to get some time for study, but basic overviews is given by me, and I think it will be sufficient. But see these videos carefully, this will be very important. Okay, so for today's lecture this will be sufficient. Okay, I am sharing one video with you. Please see that video, that will be very helpful. Okay, thank you very much.